Hello everyone, this is our lecture number 6. In these lectures, we done some examples of previous lectures where we studied the different formulas for finding the moment of resistance. So here we apply that formula and find the solutions. So first numerical we have a rectangular concrete section which is 25 centimeter wide, 50 centimeter overall depth, is verified with 3 bars of 16 mm dia. Permissible stress sigma cbc is 5 newton per mm square, sigma st is 230 newton per mm square, m is equal to 19, effective cover is equal to 40 mm. Now calculate moment of resistance. Mr means moment of resistance of the sections. So first we have to draw diagram. So here is the diagram. We have given 25 centimeter, means we convert in mm, we get 250 mm. Overall depth is 500 mm. Effective cover is 40. So effective depth is overall depth minus effective cover. This part we cover in our previous lecture. So here we get 460 as a effective depth and 3 bars of 16 mm dia. First we have to find that our section is balance section, over reinforced section or under reinforced section. For that we have to calculate XA and XC. XA is the actual depth of neutral axis and XC is the critical depth of neutral axis. So here our first step is finding the depth. So here first we find critical depth of the neutral axis. This formula we already described in our previous lecture. XC is equal to m dot C divided by T plus m dot C into D. Here C is the sigma CBC and T is the sigma ST. M is the modular ratio and D is the effective depth. So we have all values. So we put all values in this equation and we get 134.46 mm as a critical depth of neutral axis. Now we have to find the actual depth of neutral axis. So we have one formula for that. dxa square by 2 is equal to mast d minus xa. We have all values. We simply put values in this equation and we get actual depth of neutral axis is equal to 164.54 mm. Now we compare critical depth or actual depth and find this is which section we have to design, means balance section, under reinforced section or over reinforced section. So here XC is equal to 134.46 and XA is equal to 164.54. That means here XA is greater than XC. If XA is greater than XC, that means the section is over reinforced sections. So we have to apply over reinforced section formula. So for over reinforced section we have used this condition. X over is greater than XC, sigma CBC dash is equal to sigma CBC and sigma ST dash less than is equal to sigma ST. Means on behalf of sigma ST here we use sigma ST dash because we want to get same moment of resistance from compression side and tension side. So we put this value in our equations. So we have one formula for compression side, that is Bxa sigma CBC by 2 D minus Xa over 3. Here we get sigma CBC or sigma dash CBC because in this condition both are equal. So here we write sigma CBC. Now we have all values. We simply put the values in this equation and we get for 1.66 kilonewton meter as a moment of resistance on compression side. For getting this kilonewton per meter, here we divided with 1 by 10 raised to the power 6. If you not do this, you get your answer in Newton mm. Newton mm. That's why here we divided by 10 raised to the power 6. Now we have to find for tension side. But in tension side what happened? We have here sigma st dash less than sigma st and here we find sigma st dash. But in our question we have given sigma st. So how we find sigma st dash? So for that we use similar triangle formula. We get equation from this diagram. So here we get this equation with the help of this diagram. Sigma st dash is equal to m sigma cbc d minus xa upon xa. Xa is the actual depth. We have m is equal to 19, sigma cbc is equal to 5, d is equal to 460, and xa we already find. So we put this value and we get a sigma st dash is equal to 170.59 Newton per mm square. If this is under reinforced section, at that time we have to take sigma st as a value, which is already given in our numerical problem, means 230 Newton per mm square. But this is over reinforced section, that's why here we take sigma st dash as a value, and for that we have to find sigma st dash. So this is the value of sigma st dash. Now we have all values. Now put these values in tension side formula, and we get here moment of resistance is equal to 41.66 kilonewton meter. So this type of questions is solved by these formulas. Now we see another question. Here we have reinforced concrete beam of size 400 mm into 650 mm is made up of M30 grade of concrete and reinforced with 3 bars of 16 mm dia and 6 bars of 25 mm dia of Fe415 steel. Here we have given calculate the moment of resistance of beam and area of steel required for balance section. Here we have already given for a balance section. Now take M for M30 grade of concrete as 9 and assume effective cover of 50 mm. Means here we have given M value is 9 and effective cover is 50 mm. So these are some strategy which we have to follow for solving this numerical. First, for finding the moment of resistance, we have find the critical and actual depth. Then comparison of both value, find the section type under, over or balance, find compression and tensile stresses according to section type, and moment of resistance from compression as well as tension side. And for area of steel for balance section, for moment of resistance from compression side formula, put the moment of resistance in tension side formula using equation of equilibrium, equating the moment of area on both sides of neutral axis. Okay, so in this numerical I solve only moment of resistance for a first part. For a second part and for area of steel for a balance section, you have to solve. This is your work for a practice. I tell you only first part, how we find the moment of resistance for a beam for this 3 parts of 16 mm dia. The other questions and area of steel for balance section is find by you. This is your homework. This is the strategy which you use for finding this area of steel and moment of resistance. So you have to follow this strategy for finding the solution. If you found any problem, then you comment me in comment box. So these are the value which we have given. 650 is the overall depth, 400 mm is the width. So effective depth is equal to 650 minus 50, because here we have given effective cover is 50 mm. FCK value is 30, FY value is 415. So in our previous lectures we already see that there are some table which given in IS 456-2000. Here there we have given value sigma CVC and sigma ST. So sigma CVC is for M30 10 Newton per mm square and sigma ST 230 Newton mm square for bar below than 20, because it is HYSD bar. And if bar is greater than 20, again the value is 230, because this value is same for HYSD bar. Now first we have to find the area. So this is the area 603.2 mm square. Now we have to find the critical depth or actual depth. For finding that, which section we have to analyze. So here we find the critical depth. So here finding the critical depth, we use formula of critical depth, and here we find 168.75 mm as a critical depth. Now same we have to find the actual depth. So with the help of this formula we find the actual depth is 114.76 mm. So here we see that XA is less than XC. That means our section is under reinforced section. Our section is under reinforced section. So for under reinforced section we follow this condition. XA less than XC, sigma dash CBC less than sigma CBC, and sigma ST is equal to sigma ST dash. So in over reinforced section we have find sigma ST dash. In under reinforced section we have to find sigma dash CBC because we have given sigma CBC. 10 Newton per mm square is the sigma CBC value. So same similar triangle we apply and find the value of sigma dash CBC. So we get sigma dash CBC is equal to 6.04 Newton per mm square. Now we have put this value in our moment resistance formula. So we know that compression side and tension side formula, simply we have to put this value in formula and get the moment of resistance. So here we get moment of resistance for compression side is 77.87 kilonewton meter, and for tension side 77.9 kilonewton meter. So these are the values which we get from different formulas. Now in second question you have to find area of steel also. So for this strategy is given, use that strategy and solve for area of steel, and same process is done with the help of another area of steel which we have given in question, that is 6 bars of 25 mm dia. So these are the solutions, and these questions is solved like this. So you have to use this formula and find the moment of resistance and area of steel